All right, example 9 gives you this word problem about a football field. So, although it may appear flat, properly designed football fields arc to allow water to drain. Fields rise from each sideline to the center of the field, known as the crown, which should be 1 to 1.5 feet in height. The cross section of a football field is 160 feet wide, and a 1.5 foot crown can be modeled by this equation. We are going to go ahead and describe the transformation of our original graph that it's making. So, in other words, your football field is slightly doing like a hill to avoid water buildup. So, let's go ahead and look at each of the numbers and figure out what's happening to the graph. So, I always like to start off with the easy stuff. I like the up and down and the left and right. So, I'm not going to go, in order on this one. So, starting with the 80. So remember the 80 is negative here. So instead of it going to the left like it normally would, it's opposite and goes to the right. So 80 units to the right in our equation. The 1.5 in the back is talking about the fact that like our football field is 1.5 feet high in the middle. So our graph went up 1.5 feet. Okay, up. Now let's worry about the negative sign as well as that decimal that's in the front. So negative sign in the front means that we flipped our parabola from that to that, which makes sense because if you had a football field that looks like this, all the water would go to the middle. So we have a reflection. They don't give you enough room to write here. Reflection across the x-axis to make it a sad parabola. Also, because our number, our 0.00234 is a number that's between 0 and 1, I know that technically I'm going to flatten out everything. Remember, if it's a vertical stretch, it would be a number that's bigger than 1 and it would get really skinny. If it's a number that's less or between 0 and 1, or like a fraction or something, we would compress it down to make it really flat. So it is a compression. You can kind of think about it like a pressing here in the middle, and it's kind of like flattening it out. Let's go down a little bit here. We have another word problem that's modeled here. We're going to select all of the ones that apply. So I'm going to try and scoot this up and move my face over there. So let's see. We have, try to move that. Okay. We have the 118. I always like to start off with the easy stuff, and that means up. So I'm going to go ahead. Oops. Check that one off. Up. 118. I see the 251.5 negative, which technically I'm going to the right, not to the left. So I'm going to check that one. We have a reflection across the x-axis. That's what the negative is doing. So I'm going to check that one. And then we have a 0.0018. So we are compressing the graph. It's not getting skinnier. Remember, that's a number that has to be bigger than 1. We have a number that's between 0 and 1, so it's actually getting super, super flat. So vertical compression. So those 4 transformations are what's happening on this one.